So this is a 1214C PLC that we have here. Everybody should have one. There you go. The PLC, not the power supply. Yeah, bring the box out. Well, you have me totally confused. No, we just don't have the only heat we can control is that guy up there. So you can go up there and turn that on if you want to. Everything else is controlled by building and maintenance. So if you look at the top, these are our outputs. How are they worded? They got 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. And then we move over into another group. We have 0.0, 0.1, 0.2, 0.3, 0.4, and 0.5, right? Okay. This right here would be the first byte. This right here would be the second byte, even though it's not complete. 0 to 5 across the top. We're looking at that. We're looking at the inputs. These are our inputs. So inputs on the top, outputs on the bottom, right? Which is standard wiring on just about everything industrial electrical. You okay? Then my outputs run what? 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and then it runs 0.0 and 0.1. Okay. So this would be addressed as the first byte, and these would be addressed as the second byte, even though we don't have a complete byte. Everybody okay? Does that make sense? So when we address with Siemens, inputs would be addressed with an I, outputs are addressed with a Q. So they don't use O for outputs. That's a big problem you have with PLCs. Even every class I've ever taught, somebody has used an O for a 0 or a 0 for a 1, right? You understand? And then they're trying to figure out what's wrong with it. So we address Qs. Then we start off, then we come up, we have a byte number. So what byte number would this be? 0. We don't put a colon, we don't put anything. And then we put a dot, and then we put a bit number. So if I wanted to address that guy right there, it's going to be input 0.0. Quite different, ain't it? So in Allen-Bradley PLCs, we use a dot to specify a word. Siemens PLCs, we use a dot to specify a bit. So that's something we're really going to, we don't put a colon to separate the parts. So if I wanted to input a byte, I would say input, and I would put B for what byte, and then I would say byte 0. We wouldn't put a dot there because we're addressing a whole byte. It's a lot simpler. It's going to kind of mess with you, right? So if I wanted to output this guy, let's say bit 3 on this one, I would say N, right? 1 dot what? 3. And that would address the third bit in the third bit in the second word. Outputs on the top, inputs on the bottom. It's just like, yeah. So input 1.3. This is pretty standard in industry. Even when we wire power on a relay, if the relay mounts this way, we're supposed to put the input power on the top and the output power on the bottom. way. We couldn't run a motor off a PLC. We can run a relay. If I wanted to address this guy right here, then I'd use Q. Then I would say byte 0 dot 4. That's the way we'd address our ports. So you're right. It makes learning, once you learn Allen Bradley, except 500. Now 5,000, you don't. The addresses for inputs and outputs are so weird that you don't enter them. You select them. So what's nice about 5,000 is that you'll go and you'll say input. It'll pop up a table that tells you which inputs are free, and then you click on it, and it puts the address up there for you. Yeah, it's even yeah. Well, see, S7 probably won't ever change. They made a drastic change when they went from RSLogic 500 over to 5,000. The way we address, and one of the things is the way we address inputs and outputs. So on there, you just about have to select it from a menu, but it adds another step. So what it means is it's probably going to be slower than typing it in yourself. So people that type fast, this right here is nothing, right? Are we okay? This makes sense? Mm-hmm. We use the dot for the bit. It's not addressing a bit. Oh. So the dot here means a bit. It means you're addressing a bit. If you're not addressing a bit, you don't put a dot. But then you specify what size you're inputting. So if I wanted to input a whole word, I would do what? What do you think we'd put what? IW, and then we'd put a word number. If I want to input a double word, I say input D, and then I put a double word, which gives us a little problems. We're going to have to really pay attention to that. Because on Allen Bradley, when you clear something, you clear a whole dang word, right? On the Siemens, we have to remember how it addresses, so it's going to be a little different. Well, if they're saying, well, we wouldn't use a double word, you'd be wasting a lot of stuff, right? Because you'd be wasting memory. And why? Because we're not writing directly to the input. We're not reading it directly from the inputs. We're reading from what we call a data table, right? You understand? So if I used a double word and I only had 1 byte of information, then I would be wasting a lot of memory because it would assign that whole double word of memory, right? You understand what I'm saying? So right now we'll start off with bits, but later on we're going to have to clear. We'll figure out how we need to do that. So in Allen Bradley, when you fill on Allen Bradley 500, when you fill a group of locations, you're filling words. So we okay there? So the way we wire this thing up, this thing has an internal power supply on it, but it runs off DC. And the problem with most PLC internal power supplies is they can't provide a lot of power to control solid state sensors. So just about every time you're going to hook an external power supply up to these things, even if they have internal power supplies built into them. Does that make sense? So if you look on the bottom, I know I'm looking for it myself. Okay. It's at the top on this one. By the way, in Germany they call the common, they call it M. So this would be if I was going to power up my PLC, if I was going to power up the PLC, my inputs, this is where we power it up. So we call this, if we look over here, Right here it says this is a 1214, and it says 1214C. That's the CPU, and it says DC, DC, DC. What do you think that means? The first one is what powers the PLC itself. So this PLC powers off of DC. The second DC is what power is required by the input. And the third one is what power is required by the output. So this PLC is going to power up by DC. So we got to hook up a DC power supply right here. So it says 24 volts. If I can get this to focus, it was focused pretty good a while ago. It says 24 volts DC, right? Then it's got the arrow pointing in. All right, beside it, we see 24 volts with the arrow pointing out. Yeah, so this is where you could power other devices. But the problem is it's internal DC power supply. It doesn't provide a lot of current. But just about all PLCs you see out in the industry is going to have an external power supply. That makes sense. 24 volts in, 24 volts. Now, what we're going to do is, since all we're using is switches up here, is we're going to come up here, and this is really neat. So we could use this to train with, guys. So it comes with the switches, this pack that we have. And so what we're going to do is we're going to power this up. This guy runs syncing inputs. So y'all understand that? We talk about that in PLC. What does that mean? So the PLC itself uses the negative. So it means all your sensors are going to use the what? The positive. Okay. So if you look on the switches, do y'all have the switches in there? Okay. So they're up here. These little boxes right here. Come over and get y'all set. You what? Oh. So what? This is the screwdrivers we use. Now, the first time I talked to class, here's the screwdrivers I can use. Guess what? They were going to take them. So we've lost a couple of them. We're going to mount the screw. We're going to, first of all, we can go ahead and mount the screws. So what we're going to do is this little panel is set up. So we want the first one to line up with the first one on the left. We want it to line up with the plus right here. Because inputs are syncing, so we want to make sure we set these up for sourcing. By the way, the minus goes up here to the top, so we can actually power other things. What we're actually only using is the plus over here. Y'all know how to put them in, right? Y'all know, L plus, yeah. So these are the terminal boards here. So what's going to come up here? Right? Back them all the way out. You're going to have to do what? You have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them consecutive.